In this video, we're going to discuss successive events and tree diagrams. Successive events occur when one thing happens, and then after that, another thing happens. And when we're looking for the probability of these types of situations, what we need to do is find the probability of the first event, find the probability of the second event, and then multiply those together. Sometimes these problems are very straightforward. Other times they're a little more involved. For the ones that are more involved, we'll often make use of what's called a tree diagram that helps us keep track of all our information and keep it organized so that it gives us a method of solving these problems more easily. Let's look at some examples. A bag contains 5 green candies and 7 blue candies. A piece of candy is selected at random, put back into the bag, and then another piece of candy is chosen. What is the probability that both pieces are green? Before we start solving this, I want to talk about put back into the bag, that piece right there. That tells us that the first piece of candy was picked, we put it back into the bag, and then we picked the second piece of candy. This leads us to a really important term for us that is with replacement. If you see the term with replacement in a problem, that means we put the candy back in before we made the second choice, and that makes a big difference when we're looking for probability. Let's go ahead and try to solve this one. We want to know what's the probability that both pieces are green. We're going to find out the probability that the first one's green, find out the probability that the second one's green, and then multiply those together. So we start out by finding probability that the first one is green. Well, remember, probability is successes over outcomes. First thing we need to know here is how many outcomes do I have? Well, my bag contains 5 greens and 7 blues. So altogether I have 12 pieces of candy in the bag, and that's my total number of outcomes. I want to know what's the probability that both pieces are green. So the first one needs to be green, and there are 5 greens in the bag, so I have 5 successes and 12 outcomes. So that's the probability that the first one is green. Now I need to know, well, what's the probability that the second one is green? Don't get caught up in thinking, well, what if the first one's not green, then what? Slow down for a second. We want to know what's the probability that we get green followed by green. So we want to work under the blanket that these things happen. We get a green one, and then we get a green one. And what's the probability of that happening? So don't get distracted with, well, what if the first one's not green? What do I do then? Don't think about that. The first one's green, the second one's green. What's the probability of those things happening? Probability that the second one's green, well, we put that first piece of candy back in. So I still have 12 possible outcomes. And of those, 5 of them are green. So the probability that the second one's green is also 5 out of 12. Now I had the probability that the first one was green was 5 out of 12. Probability that the second one was green was 5 out of 12. And so I multiply those together, and the probability that both are green is 25 out of 144. That's the probability that both are green. If you want to write this as a decimal, you can divide those and get 0.1736. And if you want to write it as a percent, move that decimal over 2 spots, and it'll be 17.36%. Let's change this up just a little bit. We're working with our same bag of candy that has 5 green and 7 blue candies. This time, a piece of candy is selected at random, and then another piece of candy is chosen without replacement. If you see without replacement, that means the first piece of candy was picked out and it was left out when we made the second selection. What is the probability that both pieces are green? We're going to use the same approach we did last time. We're going to find the probability that the first piece is green. Well, let's see. I've got 5 greens and 7 blues, so I've got 12 pieces of candy altogether. And how many of those are green? 5. I have 5 successes and 12 outcomes. Here's where it gets a little different. The probability that the second is green Well, now I left that first piece out. So I don't have 12 pieces of candy in there anymore. I only have 11. And how many of those are green? Well, I started out with 5 greens. But the first one I picked was green, and I left it out of the bag. So now I only have 4 greens remaining. So the probability that the first one is green is 5 out of 12. Probability that the second one is green is 4 out of 11. And if I want to know the probability that both pieces are green, I'm going to multiply those together. And so I have 5 out of 12 multiplied by 4 out of 11, and I get 20 out of 132. And that's the probability that both will be green if I pick without replacement. If I want to convert this to a decimal, it's 0.1515, which as a percent would be 15.15%. Slightly less chance of getting both green this way than when I did it with replacement, because I take that green one out and I leave it out, so it's harder for me to get a green on the second draw. I mentioned earlier that sometimes these problems can get a little involved and we need to take advantage of a tree diagram. This is one of those types of problems. Let's take a look at it. A bag contains 5 green candies and 7 blue candies. A piece of candy is selected at random, and then another piece of candy is chosen without replacement. That means we're not going to put it back in before we make the second draw. What is the probability that the second piece is blue? Now you may be thinking, well, how am I supposed to know the probability that the second piece is blue? Doesn't that kind of depend on what happens with the first one? And you're exactly right. Problems that are more involved like this are when we're going to take advantage of a tree diagram. And let's take a look at that. What a tree diagram is going to do for us is it's going to show us all the possibilities and keep them organized. Here on the first draw, I can either get a green or a blue. Now be very careful here. This is not 2 different draws. This column right here represents the first piece of candy that I'm taking out of the bag. It can either be green or blue. As we've seen, the probability of getting a green one is 5 out of 12. And then in my bag I had 12 candies altogether, 7 of them were blue, so the probability of getting a blue on that first draw is 7 out of 12. And we're going to go ahead and label those. Remember, this column is just the first draw. There's not 2 different draws there. That's just the first one. It could either be green or blue. After the first one is green, I'm going to draw another piece of candy out. And after the first one's green, for the second one, I could either get a green or a blue. If the first one's green, I've got 11 pieces of candy left inside. I started with 5 greens, but I've taken 1 out, so now I have 4 greens. The probability of getting a green one again is 4 out of 11. The first one is green. I've got 11 pieces of candy left inside the bag. All 7 blues are still in there, so the probability of getting blue there is 7 out of 11. What we just did was the first one was green, and we were looking at the second draw. What if the first one's blue? Well, that's down here. If the first one's blue, the second one might be green, the second one might be blue. And now we're going to find those probabilities. So the first one was blue, and I left it out. That means I've got 11 candies left in the bag. I had 5 greens when I started, and I picked out a blue one, so I still have all 5 green ones. I had 7 blues when I started, so of the 11 left in the bag, if I picked out a blue one, I have 6 blues remaining. All of these in this column here are just the second draw. I don't have 6 draws on here. This, I either got a green or a blue on the first draw. And then for these, I either got a green or a blue on the second draw. Let's talk about all the things that we see in this tree diagram. The first one could be green and the second one could be green. I got a green followed by a green. That's how I ended up there. the first one could be green and the second one could be blue. That would be green followed by blue. The first one could be blue, the second one could be green. That would be blue followed by green. And then finally, the first one could be blue and the second one could be blue. Here I have blue followed by blue. I have 4 different paths on my tree diagram, and each one represents a possible outcome. We talked about successive events, and if I want to find the probability of getting green green, then I need to multiply the probabilities that are on that path. 5/12 times 4/11 will be 20 out of 132. That's exactly what we found earlier, and it better be. If I want to end up here at green-blue, I need to multiply these probabilities together, and I get 35 out of 132. If I want to get blue followed by green, I need to multiply the probabilities along that path, and I also get 35 out of 132. And then finally, if I want to get blue-blue, I need to multiply the probabilities along that path, and that's 42 out of 132. That's everything that could possibly happen, and all of the probabilities that go with them. Now, this particular question asks me, what is the probability that the second ball is blue? Let's see, here I have green followed by green, so the second one's not blue. Here I have green followed by blue. The second one's blue here. Those are successes. Here I have blue followed by green. The second one's green. Here I have blue followed by blue. The second one's blue. Those are successes. So I could get green followed by blue this way or this way. Or I need to join those together. I'm going to add these probabilities together. So I'm going to take the 35 out of 132 ways that I could get green-blue, the 42 out of 132 that would be blue-blue, and add those together. So to find out that the probability that the second ball is blue, I could get that with green followed by blue, or I could get that with blue followed by blue. And I'll go ahead and add those together and have 77 out of 132. The probability that the second ball is blue is 77 out of 132. If we want to write that as a decimal, it is 0.5833. And if we wanted to write it as a percent, it would be 58.33%. Let's look at one more. Using all the same conditions as before. We start out with 5 green and 7 blue candies. We're going to pick one out, and then without replacement, we're going to pick another one out. What is the probability that we get at least one green? So that means we need at least one green, one or more green pieces of candy in our 2 picks. I'm going to go ahead and go through building that tree diagram again just to help you see it. On our first draw, we're either going to get a green candy or a blue candy. That's our first draw. I have 12 candies in the bag, and 5 of them are green. So the probability of getting green on that first draw is 5 out of 12. I have 12 candies in my bag, so the probability of getting blue on that first draw is 7 out of 12. That's the first draw. Now for the second draw. The first ball was green, and after that I can either get a green one or a blue one. I'm leaving the first one out, and it was green. So now I have 11 candies left in the bag, and 4 of them are green. I have 11 candies left in the bag, and 7 of them are blue. If my first ball was blue, my second draw could either be green or blue, and this time the first ball was a blue one, or excuse me, the first candy was a blue one. I had 12, I'm leaving it out, so I have 11 candies left in the bag, and all 5 green ones are still there. I have 11 candies left in the bag. The first one I picked out was blue, so I have 6 blue ones left in there. Now if I want to find the probability of getting green followed by green, I need to multiply the probabilities along that path. And so I multiply 5/12 times 4/11, and I get 20 out of 132. If I want to find the probability of green followed by blue, I need to multiply the probabilities along that path. 5/12 times 7/11, and I get 35 out of 132. If I want to find the probability of blue followed by green, I need to multiply the probabilities along that path. 7/12 times 5/11, 35 out of 132. And finally, if I want to find the probability of blue followed by blue, I need to multiply the probabilities along that path. 7/12 times 6/11, 42 out of 132. Now I've got all the possible outcomes with their probabilities. I just need to answer the question I was given. The question says, what's the probability I get at least one green? So that's one green or more in my outcomes. Well, let's take a look at them. Here I have green, green. That definitely has at least one green, so I need to count these successes. Green, blue. Do I have at least one green? Yeah, I have at least one green. Yeah, those are successes. Blue, green. Do I have at least one green? Yes, I do. And finally, blue, blue. Do I have at least one green down there? No, I don't have any green. So those are not successes. So I could get at least one green this way, or this way, or this way. Since those are all possible successes, I'm going to add them all together. And when I do that, I'll have 20 out of 132 plus 35 out of 132 plus 35 out of 132. Finding the sum of those, I get that the probability of getting at least one green is 90 out of 132. To divide those, to write it as a decimal, I'll divide those and get 0.6818. And if I want to write this as a percent, it would be 68.18%. The probability of getting at least one green, 90 out of 132, or 0.6818, or 68.18%. Be careful and patient with these. Make sure you put the right numbers in the right places, and make sure you identify the proper outcomes that are successes.